Hello friends, in this video session I am going to discuss about kinetic energy of a rolling body. This is one of the important concept for all competitive exams after plus 2 like JEE Mains, JEE Advanced, even NEET and CUT also. One of the important concept. It is a part of the rotational dynamics. In that subtopic I am discussing now kinetic energy of a rolling body. What exactly the rolling object? Rolling object nothing but, see, let me take one circular object. Rolls nothing but it will have a translatory motion as well as the rotatory motion also. So when you talk about kinetic energy of a rolling object, it is the kinetic energy due to translatory motion and kinetic energy due to rotatory motion. First, we'll discuss what is the kinetic energy due to the translatory motion. What exactly the translatory motion? Let us suppose a body moving or executing translatory motion. Let us suppose this object. Each and every particle of that object. Let me take one particle here. If it has a speed v, take any another particle of the object, it will have the same speed v. So the translatory motion meaning each and every particle of the object will have identical velocities. Let me take one round object. Round object, it may be disk, it may be sphere, it may be hollow sphere, solid sphere, any round object executing translatory motion. Under that case also, you select any point. Let me select this point. If this point have a velocity, this point have a velocity v, any another particle of that same object. Let me take this particle also velocity v and this particle also have velocity v. Any particle of the body if it execute translatory motion, it will have identical velocities. They'll have identical velocities. So how to write a kinetic energy of a translatory motion? Simple, kinetic energy of a due to translatory motion is half mv square. You can write as half m is the mass of the object, vcm square also. Velocity of the center of mass and velocity of any particle of the body also the same. This is the kinetic energy due to translatory motion. Again we are talking about rolling, so that it is also combination of translatory motion as well as the rotatory motion. What exactly the rotatory motion? Let us suppose if you take this round object, it is fixed about this point, it's rotating about this point, then this particle will have a velocity in this direction, this particle will have a velocity in this direction, this particle will have a velocity in this direction, this particle will have a velocity in this direction. All these particles are at the same distance from the center of mass, or all these particles are same distance from the fixed point. This velocity is r omega, and this particle velocity also r omega, this particle velocity also r omega, and this particle velocity also r omega. Here direction of the particles different, but magnitude of the velocity same if those particles are at the same distance from a fixed point. And in a rotatory motion, each and every particle will have same angular velocity. In translatory motion, they will have same linear velocity. In rotatory motion, they will have same angular velocity. Once the object in rotatory motion, it's rotating, all the particles of the object moves in a circular path with the same angular velocity. Rolling nothing but it's a combination of translatory motion and the rotatory motion. Now when you talk about a kinetic energy of a rolling object, it is the sum of kinetic energy due to translatory motion and kinetic energy due to rotatory motion. See, what is the kinetic energy due to translatory motion? Half mv square. What is kinetic energy due to the rotatory motion? Half I omega square. See this in this picture, taken all the four different particles, but will have a same velocity, magnitude wise, the direction wise, it's the same. When you talk about in rotatory motion, see all the particles are taken at the same distance from a fixed point. They are also the same magnitude, but direction changes. So when you talk about the total energy, it is a sum of kinetic and Kinetic energy due to translatory motion and kinetic energy due to rotatory motion. Let me write that expression. Total kinetic energy is half mv square plus half I omega square. What is I? I is the moment of inertia of that particular rotating object about that fixed point. Total kinetic energy of a rolling object. Kinetic energy total. It is the sum of kinetic energy due to translatory motion and kinetic energy due to rotatory motion. What is kinetic energy due to translatory motion? Half mv square. Due to rotatory motion, half I omega square. If you simplify this, half mv square plus half I is mk square. It is pure rolling. Under the case of pure rolling, velocity due to translation is equal to velocity due to rotation. Velocity due to translation is v, due to rotation is r omega, where r is the radius of that object. Then omega can be written as v by r whole square. So you can write as half mv square is common. Then we will get 1 plus k square by r square. This is the expression for kinetic energy of a rolling object. Total kinetic energy, meaning kinetic energy due to translation as well as the rotation. Then sometimes you'll ask, what is the ratio of kinetic energy due to translatory motion to that of total energy, kinetic energy total. So under that case, you can write this as kinetic energy due to translation is half mv square. Total energy is half mv square into 1 plus k square by r square. This gets cancelled. You left with what? 1 by 1 plus k square by r square. And you can calculate kinetic energy due to rotation to that of kinetic energy total. So you can write as half I omega square. I is a moment of inertia. You can write mk square. Omega square can be written as v square by r square whole by total energy. Total kinetic energy half mv square 1 plus k square by r square. So you can write half mv square gets cancelled. Left with what? K square by r square whole by 1 plus k square by r square. These are the formulas you must remember. That is one total kinetic energy, that is half mv square into 1 plus k square by r square, and ratio of kinetic energy due to translation and kinetic energy, ratio of the kinetic energy due to translation to that of total, kinetic energy due to rotation to that of total. Now we'll take up some problems based on this. To improve your score, to watch more videos, please subscribe a YouTube channel, that is Time for IIT JEE NEET. Now we'll take up some questions. The question number 1. The solid sphere of a mass 1 kg rolls horizontally. Mentioned rolls horizontally without slipping. Nothing but it's a pure rolling. So mass is given. Mass given as 1 kg. With uniform velocity. Velocity is given as 0.1 meter per second. The total energy of the system, meaning total kinetic energy. You know expression total kinetic energy, that is half mv square 1 plus k square by r square. Here according to the problem, mass given as 1, velocity is 0.1, nothing but it is 10 power minus 1 whole square. So 10 power minus 1 whole square 1 plus. So solid sphere. What is the moment of inertia of a solid sphere? That is moment of inertia of a solid sphere is 2 by 5 mr square, which is equal to mk square. So that k square by r square value you can write as 2 by 5. Upon simplification, 1 by 2, 10 power minus 2. This is 7 by 5. So you can write 7 into 10 power minus 2 divided by 5 to 10. So you can write as 7 into 10 power minus 3. So answer 0.007 joules. So that is option C correct. Moving to the next question. The moment of inertia of a flywheel nothing but disc, given as 3 kg meter square. If the total energy 1350 joules, the angular velocity of the wheel, here given it's a rotating, is not mentioned whether it is rolling or rotating. Simply you can take under this case only rotation. Kinetic energy due to rotation is half I omega square. What is kinetic energy given? 1350 is equal to 1 by 2. This is given as 3 omega value that you should calculate it. Okay, 3 ones. This is 3 fours 12, 3 fives 15 and 0. 2 goes there. 450 into 2 is equal to omega square. So omega square is 900. Omega root 900 which gives you 30 radian per second. So under this case, moment of inertia of a flywheel, where total energy given as 1350, moment of inertia also given 3. So angular velocity asked us to calculate. Option A is correct. Moving to the next question. A solid sphere rolls on horizontal surface. A solid sphere rolls on horizontal surface. What percentage of the total kinetic energy is rotational? Meaning is asking rotational kinetic energy is what fraction in the total. That is what he asked. So you can write as half I is mk square. This is v square by r square whole by total kinetic energy rotationally asked, right? Then divided by total energy is half m v square 1 plus k square by r square. So you can write, you left with what? K square by r square. Here 1 plus k square by r square. For solid sphere, just a moment back we calculated, that is k square by r square value is 2 by 5. This is 1 plus 2 by 5 which gives you, this is 2 by 5 and this is 7 by 5 which gives you 2 by 7. He asked percentage. So percentage, kinetic energy percentage he asked. So 2 by 7 into 100, that gives you 200 by 7. 7 twos 14, left with 6. So 60. So 7 8s 56, 28.6 percentage. So option C is correct. Option C is correct. Question number 4. The speed of a uniform spherical shell, halo sphere. So spherical shell meaning halo sphere. The radius r after rolling down on an inclined plane of vertical height 3 meter from rest is. Here the problem is there is an inclined plane whose height is given as 3 meter. Spherical shell rolling down from rest. Here the velocity is rest. Velocity is 0. Sorry. And what is its velocity on reaching bottom of the inclined plane? He asked. We can use energy concept. Initial energy is mgh, where m is the mass of the spherical shell. And finally it will have a kinetic energy. Rolling kinetic energy is half m v square into 1 plus k square by r square. Then you can write m and m gets cancelled. gh is equal to v square by 2 1 plus, it's a spherical shell, that value is 2 by 3, k square by r square is 2 by 3. So 2gh is equal to v square. This gives you 5 by 3. So finally v square is equal to 6gh by 5. So v is equal to root of 6gh by 5. Now if we substitute the values, 6 g is 10, H given as 3 meter and 5. So this gives you 5 ones and 5 twos, 2, 3, 6, 6, 6, 36. So velocity is 6 meter per second on reaching bottom of the inclined plane. In JEE mains, you know, some questions are 5 questions are numerical type of question. This is one of that. Thank you.